Hello everyone. Welcome to the class of design and analysis of an algorithm. Today we will see lecture number 9. Today we are going to see what is a master's theorem of recurrences. As I said in the last lecture, the recurrences are the equations, right? Now, if I gave you the examples of what type of equations we can have in order to solve them. We use Master's theorem for solving the recurrences, but always remember we cannot solve each and every recurrence using the Master's theorem. We can solve such equations which will fall under this form. So, what basically is a Master's theorem? Master's method provides a cookbook method for solving recurrences of the form. Cookbook, why? Because everybody knows whatever is written in cookbook, the measurements we have to cook accordingly. Similarly, we have to strictly follow this theorem in order to solve such examples. That recurrences. That is the reason why it is called as cookbook theorem. We can solve the Master's theorem, which is of the form T of n is equal to a times T n by b plus f of n, where this a should be greater than or equal to 1, b is greater than 1 are constants, and f of n is a positive function. Okay, let me first explain this. To use the Always remember, in order to use the Master's theorem, you will need to memorize three cases. These are the three cases. Case number 1, case number 2, and case number 3 over here. Then you will be able, then and only then, when we will remember all these three cases, then and only then we will be able to solve many recurrence problems, equations very easily. This recurrence, that is this equation, this form, basically describes, or I can explain this to you, that this is the time complexity or the running time of an algorithm on an input size n that basically divides a problem of size n into a subproblems, each of which each subproblem is of the size n by b, where this a and this b are positive constants. The a subproblems are solved recursively, each in the time t n by b. The function f of n causes to take place the cost of dividing the problem and combining the result of the subproblem. How much time this bigger problem will take to reduce, to subdivide the subproblem of size n by b, okay, and then combining the solution of the subproblem, that holds in this function f of n by b, okay. This was about the Master's theorem. Now, what this theorem actually tells us? So, Master's theorem depends on the following theorem, and the theorem is that this t of n is equal to a t n by b plus theta of n raised to power k log raised to power p of n. And these are the conditions that this a should be always greater than or equal to 1. It should not be less. This b should be greater than 1. If this b will be less than 1, that means our problem, we're not, by writing b is less than 1, that means we are increasing our problems, we are not reducing the problem into the subproblems. And this p is a real number, and there is a constant k. This should be greater than or equal to 0. After having a recurrence, we have to see if a is greater than b raised to power k, then solve the recurrence using the formula. If this a is equal to b raised to power k, then check the three conditions. Whichever will be satisfied, solve your recurrences accordingly. We have to check if p is greater than minus 1, then your recurrence will be equal to this. If p is equal to 1, then your recurrence will be equal to this. If p is less than 1, then this will be equal to this, okay. And the last condition is If a is less than b raised power k, if p is greater than 0, then t of n is equal to theta of n to the power k log p of n. If p is less than 0, then t of n is equal to theta of n raised to power k. Okay, so this is a theorem which you have to memorize, which you have to remember in order to solve different recurrences. Let us take one example and we will try to solve this. See, say for example, you are having a recurrence like this. T of n is equal to 3 of t n divided by 2 plus n ka square. That means a bigger problem is divided into 3 sub problems and 3 sub problems. That means 3 sub problems ka size hai tn by 2. Okay, and they are doing some another work, another function of type n square. The cost will be of n square. So in this case we have to check. In this case a is equal to 3 or b is equal to 2. According to the condition, r a should be greater than or equal to 1. Is it a is greater than equal to 3, greater than or equal to 1? Yes. B should be greater than 1, 2. Okay, correct. Rk is equal to 2. It says there is no, okay, k is equal to 2. Okay, then p, there is only single term, there is no log pn like this, so that is omitted. Take that equal to 1 or nothing, so p will be equal to 0 because that is not given to us. Okay, now we have to check the conditions. The first condition is if a is greater than b raised power k. A is equal to 3, b is equal to 2 and k is equal to 2. So if a is greater than b raised power 3 is greater than 2 raised to power 2. 3 is greater than 2 to the power 2 is 4. So yes, 3 is greater than, 3 is not greater than 4. That means we cannot. Obviously it is not equal to, that means 3 is less than 4. That means our third condition would get checked, right? 3 is less than 4. Now after seeing that third condition would got satisfied, now we have to check these three. If b is greater than or equal to 0, is it equal to 0? Yes. That means we have to solve our this recurrence using this equation. T of n is equal to theta of n to the power k log of p of n. Okay, so t raised power n is equal to theta of, this term is basically not given, and k is 2 log of 0 into n. What is n given? N is not given to us, so into n. So this is this another term, this is log of 0 of n. We don't have to consider this because there we have a log of n. So t of n will be equal to theta of n ka square. So this is how we solved this. Okay, let us take one more example and we will see how we can solve this. If we have, say for example, okay, see, if we have, okay, like this question, t of n is equal to 2 to the power n, t times n to the power 2, n divided by 2, n raised to power n. Okay, so this is the equation. We want to solve this recurrence using the master's theorem. The question is here, a is equal to what? 2 to the power n? No. Why? Because our a must be of this form. It should not be the exponential. Okay, so we can simply write a should be the constant because that is the condition for the master's theorem, and in this case our a is not a constant and a should be greater than or equal to 1, so it is not in the form of master's theorem, therefore we can't solve this. Tomorrow we will do many more examples from the master's theorem, but I will give you 2-3 examples which you can do at home, like t of n is equal to 2t n divided by 2 plus n log of n. Say one more question is t of n is equal to 2t n divided by 2 plus n divided by log of n. Try to solve these two at home and let me know. Thank you.